Hi everyone, here we are for the third part of Chapter 7. So we've covered how the immune system works, and now we're going to look at immunity. Immunity is the ability to combat diseases and cancer, so the ability to fight it off. This can happen naturally by obtaining an infection and then your body making memory cells, or it can happen artificially by getting medical intervention. And this is what we would call a vaccine. We also have two types of immunity, which are active and passive. So that has to do with how you obtain them. So in active immunity, the body is going to make antibodies in response to an antigen. So active immunity, you actively are producing antibodies. They're in a vaccine situation, that's what we see in our graph here. So we have first exposure to the vaccine happening at time 0, and in response to that, your antibody concentration is going to increase because the B cells are activated, the plasma cells are making antibodies, but that dies off. And at about this time, this is when you usually get your booster shot or your second exposure to the vaccine. And once the body, within that short amount of time, has been exposed to that because it's a vaccine, just a small piece of the pathogen, basically the antigen, once it gets that second exposure, the number of antibodies really jumps up, and it remains high enough the rest of your life that it's ready to respond to any third or fourth or fifth exposures. It's able to respond so rapidly that you never actually contract the disease. So that's what a vaccine is doing. It's why getting the booster shots is really important. Otherwise, you would just stay down here at 0 and you wouldn't actually have the benefit of the vaccine. So that's active immunity, where you're actively making antibodies. In naturally active immunity, naturally acquired, that's because you were exposed to an infection. In artificial active immunity, that's when you were exposed to a vaccine. So natural active immunity, exposure to an actual pathogen; artificial active immunity, exposed to a vaccine. But in both instances, your body responded to an antigen by making antibodies. Now, passive immunity is when the body or a person is just given antibodies straight up. They don't actually make the antibodies, they actually just get the antibodies. And that, again, is going to protect against an antigen. So passive immunity is pretty short-lived. It does not last your whole life. Sometimes it doesn't even last a matter of weeks or months. It would just depend. So it's very short-lived compared to active being your whole lifetime. So in naturally acquired passive immunity, antibodies are passed either through the placenta from the mom to the baby or during breastfeeding from the mom to the baby. So both of those are two natural ways to get antibodies from, in this case, mom to the baby. In artificially passive immunity, you actually just get an injection of antibodies, which is what we see this boy getting on the bottom picture. So we actually are able to take antibodies out of donated blood. We're able to put them into a solution and then inject that into your body. So again, both of these, or all three of these, are short term. So the protection, unless you keep getting injections or you keep getting breast milk or you keep being a fetus with placenta around you, and as soon as those things end, your immunity would also end shortly after that. Allergies are something that many of us have experienced. They are a hypersensitivity to a harmless substance, such as pollen, food, or animal hair. So something that really, an animal hair that gets into your nose doesn't actually do you any harm, but your body recognizes it as having a foreign antigen and kind of responds thinking that it needs to attack it. So that's why you get a runny nose or itchy eyes, because your body's trying to produce extra fluids to get that pathogen out of the body. And a very, very strong allergic reaction, of course, can be harmful if we have anaphylactic shock. But again, it's really just a hypersensitivity. It's your immune system overreacting to something that's harmless. A tissue rejection is essentially an allergy to someone else's tissues. So what's happening in a donated organ is given, and then that body starts to reject the organ, is that the cytotoxic T cells are responding to the donated tissue, not recognized as self. So the cytotoxic T cells finally can go up to that new piece of liver, and when they feel the outside of those cells, they might recognize it as not being your cells, because T cells, when they mature, are more or less taught to recognize your own antigens. So then it starts to attack it, thinking it is foreign, and so we want it to stay in your body. We don't want it to leave. So your body's supposed to protect you, but in this case, it's overreacting, and we're essentially trying to trick it. So what we do right now to control tissue rejection, to try to make these organ donations more successful, is that people who are receiving an organ are given immunosuppressive drugs. So they actually are suppressing their cytotoxic T cells when they are receiving that organ, so that there is nothing there to attack the donated organ. And the other thing we do is we try to transplant organs with the same antigen proteins in the donor and the recipient. So this is why we tend to look to family members first, just because with genetics it's more likely that they would have a match, but they don't necessarily have to have a match. And then there's all these different antigens on your own cells, and for the donors, those antigens would be listed in a database, and then they try to find a good match, and as many matches as they can. A couple other disorders of the immune system include autoimmune diseases and immunodeficiency diseases. And both have immune something in the name, so it's easy to get them confused, even though they are two different things. So autoimmune disease means that your cytotoxic T cells, or your antibodies, attack your body's own cells. So this is when my own CT cells are attacking my own liver. The examples that you might have heard of include rheumatoid arthritis, multiple sclerosis, lupus, and myasthenia gravis. There are many other autoimmune diseases but we didn't list here, so you might have heard of some others, but those tend to be more common ones. Immunodeficiency is just what it sounds like. You have a deficiency of your immune system. So immunodeficiency disease is when your immune system is compromised for some reason and thus unable to defend the body from disease. Sometimes that reason is genetic. Sometimes that reason is that you were previously exposed to some sort of pathogen that's debilitated your immune system. That's the case with HIV and then AIDS. And a genetic example is SCID. So there's a few different options or ways this could present itself. So to wrap up this part, we're going to look at herd immunity. And this is the idea of how vaccines can protect people who can't receive vaccines. So this would include folks who might be pregnant at the time, or receiving chemotherapy or radiation, or people who have an immunodeficiency disease. And so the idea of herd immunity is that when I am vaccinated, I am protecting myself, but I'm also protecting those people around me. So if this is our infected person and we have a non-vaccinated community, everyone in pink is susceptible to the disease. And so as this dark gray person, infected person, comes in contact with those pink folks, the infection can spread throughout the community as those people interact with each other. But with herd immunity, in a population that has been vaccinated on the right, when the infected person comes into contact with vaccinated people, that's where the infection stops. It doesn't actually spread to anyone else. So essentially this herd is protecting these people in pink who can't be vaccinated for any reason. Maybe they have SCID, maybe they have HIV, maybe they're pregnant, maybe they're receiving certain treatments that has lowered their immune system's ability to respond to an infection. But by being completely surrounded by people who are either resistant to the disease or vaccinated, we've essentially protected them from that infection. So herd immunity is great. It's what allows us to keep people safe who can't get vaccines, especially babies or kids who aren't old enough yet to receive certain vaccines, and other folks too. But it only works if a critical mass of people are vaccinated in the population, and the more people who are vaccinated, the more protection there is in the herd immunity concept.